Hi, welcome to today's lesson on scale factor. For those of you who've been watching most of my videos and are in order, you'll notice that I have gotten the cast off and now I have just an arm brace. So I'm gonna go a little slow just because using this arm is challenging and it is what it is. So I hope it's as legible as I'm expecting it to be. So today's lesson is all about scale factor. Well, let's start out with what is scale factor. Okay, so scale factor is it's a relationship, and we're probably going to see this as a proportion between the measurements of a drawing or model. Oops, missed my O there. Or a model to the real item. And you might see this in, let's see, when you bought architect, I think probably the most obvious, right? They draw it and then you build something that's, this drawing there's a line on the drawing that represents, it's 4 inches long, but that might be 40 feet when you get to the real item. Also, it could be you work in special effects and you have to build, a scale model of the building of something you're going to blow up, or just, because that's where you're going to animate it, or who knows. There's lots of applications of scale factor. They kind of sneak in where you didn't expect them to be, because really it's anytime you want to see something and you want to work with, you can't work with the real item because it's too big. So you want to work with a smaller version of it. Now, for me, the one that I used, and I really recommend, especially if you're going to be living anywhere but your parents' house, is when you buy a house or even rent a house or rent an apartment or even get your own room in a dorm, for example. Because one of the things that's really great to do is create scale models of your furniture, of your belongings, before you start moving in and then realize, oh shoot, we put the couch down and now I want to put something on the other side of the couch. Or maybe I put the bed down and I want to put a nightstand on the other side of the bed, but now I got to maneuver around the bed, in which case it's a challenge. But if you had started with a scale model, mapped out the room the way you wanted it, you would know to bring in the bedside table first, and then the bed, and then maybe the other side of the table. Who knows? Or the dresser. All of these sort of things can be accomplished by using scale models. And how you do that is you draw scale factor models. Okay, not just, hey, I just drew a picture of a bed and a picture. No, it's to scale, meaning that every inch of the model maybe represents a foot in the real world. So that's one of the biggest applications of it. Now, the other thing it can be is it can also be a proportion between two similar shapes. Now, when I say similar, I don't mean like they look kind of close, or hey, they're both rectangles, or hey, they're both triangles. They have similar in this case kind of has a very specific meaning. And we are going to see that in the next lesson. We're going to talk all about similar shapes. But a similar shape has a very specific, they have to have some things about them that are identical. And in regards to shapes, the things that have to be identical are all the angles. So they should look like exactly the same shape, just one bigger than the other. Okay, not like, hey, this is one kind of triangle and this is a different kind of triangle. That's not similar. Okay, so, a rectangle and a square are not similar. We don't use that term in math to describe two shapes that maybe are in your mind you think, well, they're similar, they're close to the same. Similar in mathematics has a very, very specific meaning that we'll talk about in the next lesson. But the most important part of that is that they have to have all the same angles. And you'll see, again, I'll mention that in the next video. So when you're describing them, you better be describing the same shape. You want to talk about two isosceles triangles? Okay. You want to talk about two right triangles? Now we can start to discuss. And even then, you need even more specific than that for them to be actually similar. So for our purposes, we're just going to assume that I'm describing a similar shape. So now, honestly, I'm just looking at my spacing and how I don't think I'm going to be able to write down there with this. So I'm going to keep erasing and writing up high. So I probably could have just made this video from here up. But so again, obviously, if you need to, you can always go back and rewind and pause and write down everything that I wrote down or take a note on it about what a scale factor is. Oftentimes in problems that we're going to see math-wise, the scale factor is going to be given. Okay? And that's going to be true even if in the real world too. If you go buy a model kit, for example, it'll usually tell you what the ratio of the model is to the real thing. That's something called the scale factor. So they tell you this is a 1/50th model. You build this car, the real thing is 50 times as big, meaning that every little inch on this model represents 50 inches on the real thing. Okay, that's what a scale factor is, and that's how we use scale factor. And we can use it, again, we can use it in models, we can use it in drawings. Those are the most common. And then for us, for math, we're going to see it in shapes. So those are the big three, right? Models, this is a little teeny version of the real big thing, or drawings, I'm trying to figure out where things are going to go in a room, so I'm drawing out every room, you know, how big is that window, how in real world, how big is it going to be on my drawing? And then the third is going to be similar shapes, and we're going to talk about that right now. So if we have that the scale factor is 1 to 4. It's pretty straightforward. Every one, whatever measurement it is 4 measurements on the other. And without being too, obvious, I guess, smaller drawing, bigger drawing, smaller shape, bigger shape, model, real thing. Okay, because obviously 1 inch here is 4 inches there, 1 foot here is 4 feet there, and so on. So we're going to have to know what the scale factor is before we even start, if that's what we're working with. And in this case, we're going to talk about we're going to talk about some triangles. So we can say the hypotenuse, which is the longest side of a right triangle. We'll spend a lot of time talking about that if you go check out my videos on Pythagorean theorem and right triangles, which I haven't made yet, but they're coming, of the larger triangle is 20 inches, period. What is the length of the smaller, boy, that's a terrible S. Let's try that again. Smaller triangles hypotenuse. Maybe in retrospect should have had my my wife write this all out, because then it'd be a lot easier to read. But I thought it was going to take up too much space, so I had to give it a try. So we have a scale factor. So we know that the large triangle, we know that the relationship is 1 to 4. And what is this going to create for us? A proportion. That is what it's going to make for us, and that is something, again, it keeps coming up. Okay, the whole world is full of this proportional reasoning. Well, we already have the scale factor is 1 to 4. Sometimes it'll even be they'll just refer to it as scale. If they say it's a scale drawing or a scale model. If they ever use the term just scale, what they're really saying is scale factor. Make that A. Okay, so it's not that they're just like, hey, I didn't want to. That's what they mean. When they say scale, they're saying it's scale factor, and the scale factor here is 1 to 4. Well, what do we know? We know that the larger triangle is 20 inches. And we were asked what's the smaller triangle's hypotenuse. And hopefully that's a pretty clear setup. You can see what's going on there. You can immediately see relationships between them. Hey, the large, the big numbers are on the bottom, the large numbers are on, the smaller numbers are on the top, the bigger numbers are on the bottom. And some of you, I'm sure, can probably see what that answer is, just off the top of your head. But I like to, be thorough. We're going to still cross multiply. So 4x equaling 20. And I'm going to keep the measurement, 20 inches, because then when I divide by 4, my answer is going to have the measurement as well. So I know that the smaller triangle's hypotenuse is 5 inches. So I have two similar shapes here. That's what when they talk to me about scale factor, they're already telling me the shapes are similar. So I don't have to guess. I don't have to say, well, I suspect or I wonder if. If they're telling me there's a scale factor between the two drawings or between the two shapes, then they are automatically telling me that they are that they are similar drawings. So I can immediately set up that proportion and then solve it. Okay? So there are two possibilities, really, of the kinds of questions you're going to encounter. Here, we told you what the scale factor was, and then gave you one of the measurements and asked you for the other. Okay? The other way that they'll do it would be to give you the two measurements of the two shapes, and then just ask you, what's the scale factor? And honestly, all that turns into is reducing a fraction. So if I tell you that, let's say the drawing is 5 inches on the side, okay, and the real item could be a building, could be a wall in the inside, something. Let's make it 3 feet. Okay. And then they'll say, what is the scale factor? And that might be important because not only, so once you find the scale factor that exists between the drawing and the real item, then you can apply that over and over again to the rest of the drawing. Maybe that would let you tell, that gives you well, then I know how long that other wall is, or how long all the walls are. Like I said, when you buy a house, this is a big deal. If you want to replace a window, you're not going to, you might measure it, but maybe it's, maybe you're doing something else that's harder to measure or longer to measure, like the whole back of the house. If you've got your little scale drawing, which they do give you usually when you buy a house, you can just measure it and go, hey, I know that's this long, therefore I know the real thing is that long. Okay, it's great. Also, if you want to hang pictures, you can know how far apart you want to hang them, all kinds of things. There's a lot of applications once you start looking at your house, where you're living. Okay, you could rearrange your room. Maybe you want to rearrange your own room. But before you start just moving furniture randomly, figure out what the spacing is. Figure out where, how much space do you have? How big is the bed? Okay, make a little scale drawing of your whole room with little cutouts. Then you can just you can move things around, turn things around, it'd be great. Now the other thing that stands out about this is that the drawing is in inches, but the real item is in feet. And if you're going to find a scale factor, you got to be working with the same units. So when we go to find our scale factor, we're going to have to change our feet. You always go down in units. We're going to have to change feet into inches. So 3 feet would become 12 inches for every 1 foot. So I can reduce the units, and now I have 36 inches. Now I can set up my ratio. And in truth, when you talk about a scale drawing, they always will go small to large, but they don't have to. You could go large to small if that was something that you would rather do, if you think that would make more sense or be easier. You are always allowed to do that. So, but we would simply go, again, for our scale factor, we're going to go 5 inches to 36 inches. And honestly, I'm going to change this right now, right here in front of you on the video. We're going to make that 6 inches because I want to reduce. So that's 6 inches. So that now I can reduce this to 1 to 6. And there's my scale factor. I could have left it at the 5 to 36. It's a scale factor. There's nothing wrong with it. It's just, I like the idea of reducing and being able to say 1 to 6. But the truth is, 5 to 36 would have been a perfectly legitimate scale factor, because in reality, you know, sometimes that's the way it is. It's, you know, the drawing is this big, the real thing is that big. They're related 5 to 36. For us, I liked 1 to 6 as a scale factor. So really, you got two possibilities. They're going to give you the scale factor and ask you for one of the two measurements, real or you know, big or small. Or they're going to give you the big and the small, and they're going to ask you for the scale factor. And then there's, I guess, a third way you could throw it at you. They could give you, you know, the big and the small of one set, which lets you find the scale factor, and then let you use the scale factor to find the big or the small of another measurement. So you use the known ones to find scale factor, then you use the scale factor and one other known one to find this missing item. And that could be on similar shapes. We'll certainly see that quite a bit, especially in the next lesson. Or it could be in, you know, measurements of the house. You know, we know in the drawing that the eastern wall is this long. We know the real wall is this long. We know that the drawing is this long. How long is the real back wall, the north wall, for example? And you just find the scale factor of those and apply it to the drawing to find out what the northern wall would be. All right, well, that was the experiment for the writing with this hand. I hope that was legible, as it looks legible to me at least. It was a bit of an exercise, probably overdoing it here with this arm, but hopefully the next one will be better, a little bit easier. Until then, I look forward to seeing you in class or in office.